Welcome back to the shop and to the channel. Well, this is my Brown & Sharpe universal dividing head. I've had this for a little while. This is a very handy tool to have in the shop. It can be used for making gears. It can be used for making anything in which you need to divide a piece of material by some number by using these indexing plates that sit on the side of the machine. I've had this for a while and I've used it on several occasions and I really like it, but I feel like it's kind of stiff, and I think it's because it is packed full of nasty, dried, used up old grease. You can see some of it coming out of the back of the spindle, some other nasty grease coming out of the side of the gearbox. I think it probably has never been really maintained internally. For the most part, it's in really good shape. I really don't have any complaints about it. It doesn't look like there's anything on it that's actually broken. But I want to use this in conjunction with the servo motor to drive it with my DIY Dr. DRO that I have on my Kearney and Trecker milling machine, and may end up also on my Bridgeport. I'm thinking about making another DRO for the Bridgeport, so I can use this on the Bridgeport as well. But before I jump into making this accessory drive for it, I really want to clean this thing up. It's not too terrible on the outside, although it does have quite a bit of oil staining on it. It's really what I'm afraid I'm going to find on the inside. So after taking off the chuck, which I might look for a different chuck for this thing, I want to start diving into the inner guts of this tool and start getting it cleaned up. See what we find. There's not a whole lot of information out there on how this thing comes apart, or what the internal workings look like. I do have a manual from Brown & Sharpe, but it's for a different version. There's some obvious differences on it that you can tell from the diagram, and I suspect the internal workings will also be different. Keith Rucker did a video some years ago on a Brown & Sharpe clone, but again, looking at his versus this one, there's some obvious differences. So I suspect that even though that video might be some good reference for me, there's going to be some considerable differences between the two, since this is a true Brown & Sharpe. So the best thing I can do is just forge ahead and be careful. And part of the reason why I do these videos is because I can refer back to them and make sure I know how to put it back together once I get it apart. I machined these keys to be a nice tight fit, and boy are they. So I'll get these out of the indexing slot here on the bottom and figure out just what I want to start taking apart next and what's after that. I am going to start by removing the index plate and all the mechanism associated with it, including the index crank, I think is what this might be called. Don't really know, because the parts diagram I have has a bunch of numbers on it, but it doesn't really indicate what these things are called, so I guess I'll just make up the names as I go along. Next, I'm going to remove these 3 screws that hold the gearbox cover on and see what kind of mystery waits for me underneath. Yeah, that's pretty gross, although it's not as bad as I was expecting it to be. Looks like someone used some white lithium grease in here. I don't know if that's the right grease or not. While I'm here, I might as well go ahead and take this gearbox apart. I'm using an impact driver here. It's a low torque one, and it's just really to break loose these fasteners. It's not strong enough really to do any damage. I like using it for stuff like this, just to make the disassembly a heck of a lot easier, and I don't have to worry about clamping something in a vise or something like that. So I'd already loosened this other nut off before I took the gearbox out, so I just need to figure out what shafts need to come out first in order to get these gears to come loose. Really couldn't figure out a good way to hold the gearbox in order for me to drive this shaft out. So I did end up putting the gearbox case itself into my vise, protecting it with some aluminum shims here. And that made it a bunch easier to get the shaft out so I can get it all cleaned up. There's a lubrication note here on this plate that's screwed into the side of it. I'm hoping that when I remove it, we might see the original paint color. I don't know that I'm going to repaint this piece, I might just clean it up and call it good. The trouble is, some of the things that I use to clean these parts up with will eat the paint. And so if I spend too much time or use the wrong solution to clean this off, I might end up damaging the paint. I don't know that I want to repaint it. I don't know that I'd be able to find this paint color, at least not locally. So I might just leave it as is. There's another cover here on the other side of these gears that's held on with a couple of screws. Now, from Keith Rucker's video, his, I believe, was brass. I can't really tell if this one's brass. It looks like it's been painted. With that cover off, I can slide off this hub in gear. I'll take off this degree pointer that's screwed to the back of it, just to kind of get it out of the way. I don't think it's really going to interfere until I remove the dividing head from the base, but it's pinned in place, which is for locating it, at least some level of precision. So I just want to make sure I don't snap off that pin trying to take this out. There's quite a few Zerks on this machine, and normally I would think that these are oil Zerks, but based on the little instruction plate that I removed on the gearbox cover that mentioned using a non-fibrous grease, it appears that this thing is lubricated with grease and not oil. So this little plunger here is for locking the dividing plate in place. So I'll get this out of here. I need to figure out a few things here before I can take off anything else on this side of the machine. Well, there's another Zerk here at the top rear of the tool, and this one was in there pretty tight. I presume this is a Zerk to grease the rear bearing. Well, bringing my attention back here around to the front, it might seem like I'm bouncing around a bit, and I guess I kind of am. As I notice things is usually how I operate when disassembling a tool. I got that grease Zerk off because I saw it, so I did it. So now back to the front here. This plate that's on the front of the dividing head has equidistant holes in it that make it a little easier to do direct indexing, where you don't need an indexing plate on the side of the tool. You can just use this plate, and there's a plunger at the top that indexes into the holes. And so I think these are in 15 15-degree increments. So it's a press fit on the front of the spindle. So I'm just using this little brass hammer to bring it forward to come off the spindle. Well, I think the most challenging part of this disassembly is going to be removing this nut off of the back of the spindle, which I presume is for setting the preload on the bearings. The only spanner wrench I have is this cheap adjustable thing that I got off Amazon, and it barely fits in here because of the nature of the way this nut is recessed in a curved surface. The pins barely fit into the holes, and when I try to use a little percussive force to move the spanner wrench, it's rotating the spindle, which means I need to engage the drive mechanism to get this to stay in place. This might take a lot more effort than I originally anticipated. It looked like it was moving, but now looking back at the position of that key slot, all I did was turn the spindle. Well, if I rotate the cam here that engages the worm with the spindle and lock everything in place, maybe that will hold the spindle in place enough that I can get the spanner on it and see if I can't get it to turn. Well, I have a punch that will fit into this hole, but to be honest, I absolutely hate using punches like this because all it does is deform the hole, and I really would rather avoid doing that in its entirety. So I don't know if I'm going to pursue this method or not. While I am pondering my life choices and why I decided to disassemble this thing and how I'm going to get that nut off of the back of the spindle, I'm going to distract myself a bit and remove these nuts that hold the clamps that set the angle of the dividing head. With the clamps removed, that should allow the dividing head to freely move in the dovetails of the base, which may be a good thing or a bad thing. We'll find out. Well, I have some penetrating oil here. I'll spray down into the dovetails and see if we can't work the dividing head loose. At least bring that rear spindle nut up into a position that might make it a little bit easier to work on. I got a piece of copper pipe here so I don't do any damage to the inner bore of the spindle. Get this worked back and forth and hopefully put it in a position that'll make it easier to use that spanner wrench. Well, I'll try to clear out some of the overabundance of dried grease because anything that's going to hold up this nut from being removed, I want to get it out of the way. Even some dried grease can definitely have an effect on how easily something comes apart. So it's worth it to spend a little bit of time here to try to clean this up at least somewhat. Well, I noticed here on the back of the spindle, looks like there's a bit of a burr. Not sure where this came from. It was there before, but take a little chisel here to try to chip that off. Maybe that's what's holding me up. Well, this is still not going well. So I think what I'm going to do is I'm going to soak this in a little more penetrating oil and let it sit for a little while. Maybe that'll help. Well, I came back in the next day, let that soak for a little while, and giving this another try. But quite frankly, the only thing that I'm succeeding in doing is doing more damage to that cheap spanner wrench. So I think it's time to look at making a tool to do this. I think what I'm going to do is I'm going to make a 4-pin spanner wrench. I've got the materials here that I can do that with. So I'm just going to take some quick measurements of the back of the spindle here and try to figure out the dimensions of how big this thing needs to be and find some material and start making a tool. Well, I found this piece of scrap in the drawer that should make a decent hub here. It's considerably oversized for what I need, but I'll chuck it up here in the lathe and we'll turn this down considerably to get it to a dimension in which I can weld some pins to the outside of it to fit into those 4 holes in that nut. Well, I want to recess the inner bore of this, or the front face of this tool, so it will fit over the rear of the spindle, just so it doesn't interfere with it. So I don't really have the right lathe tool to do this, so I'm kind of winging it with this one. Well, I can't really reach in there deep enough because now the tool holder is rubbing on the face of this piece of material. So I'll put the boring bar in here and give it a try. Although later, really, I kind of find out that this was pointless. I really didn't even need to bother with this. I need to drill a hole all the way down the center of it. I'm going to take a piece of hex stock and turn a spigot on the end of it and press it into the other end for a driver. I'll use some anchor loop here on the end of the drill. I want to be able to drive this with a ratchet, so I've got a piece of hex material here. I'll chuck it up. I'll turn down a spigot on the end that I can then press fit into the back of the other piece I just made. Well, I can't leave the other end just as a raw saw cut, so flip it over here. I'll face it off and then chamfer the edge. I'll press this piece of hex into the back of the tool. I did put a little bit of Loctite on it. It's about a 2000s interference fit, so I'm hoping that it's going to be tight enough that it'll hold for when I go to use it. With the hub of this tool made now, I want to clean out these pinholes and get an idea of the length that I need to cut these pins at. I've got some mystery pin material that I found in a toolbox somewhere, and I'm just going to set this up here and mark it for length. We'll go ahead and cut 4 of these pieces and take them over to the welding table. Well, I have this set up here on the welding table. I am going to use TIG here because I don't want the splatter from MIG. And I am going to attach the ground clamp to the hex bar on the back of this tool. I want to make sure that the welding current, does not go into the dividing head. The worst thing that you could do is weld something where your ground strap, in order for the circuit to complete, would go through bearings. You're going to create arcs and likely weld the bearings to the races. At worst, at best, you're going to get some pitting on the bearing rollers or the races caused by that arcing. So by attaching the ground clamp to this hub of the tool, that creates the electrical current is staying within the tool, and it's not traversing into the bearings or into the dividing head. There is no danger whatsoever of damaging the tool by doing it this way. So right now I just want to get these pins tacked to the hub, and once they're tacked, I'll take it off of the dividing head and finish welding them on the table. Well, this is already starting off poorly. I was welding this on here, and I don't know what kind of material this pin's made of, but I melted all the way through it. I would have expected something that's 3/16 of an inch to be a little hardier than that. I don't know. Maybe this is kind of tool steel that doesn't weld very well. I'm also wondering, is the hub made out of leaded steel? It's welding, so I'm assuming that it's not. But 3 is not as good as 4, but 3 is better than 1 or 2, so I'm going to keep welding these other 3 in place. We'll get this last pin welded on here. I'm going to let this cool down for a while, and then we'll give it a try. It's been a bit here, but this thing is still pretty warm. This thing only fits in one way, and that's probably because the holes in the spanner nut weren't drilled perfectly, or it's more likely because I did a poor job of making this tool. I don't know. But either way, it fits. So let's give this a little try, see if we can't get this nut off. Well, as I apply some force to this new tool to take this nut off, I'm going to need this dividing head to be held in place. So I'm just going to put a bolt here through the rear mounting tab and just bolt it down to the table. Nice thing about this Certiflat table is it's got all these holes in it, which are super convenient for stuff like this. With that now nice and tight down to the table, I can put a ratchet on this tool and see if this thing's going to budge. Well, that didn't go anywhere near as planned. 2 of those 3 pins just completely snapped off. So whatever that material was made out of, when I welded on it, it made it extremely brittle. Well, back to the drawing board. Well, I'm not going to give up on making that tool. So I did have over in the stock bin here some 3/8 TPG that I know is decent material, although it's just too big, it won't fit into the holes on the spanner nut. So I'm going to turn down just the end of these a bit and see how that goes. So I'm going to get my micrometer carriage stop here set up. I've got a spacer that's going to represent the length of that shorter part of the pin. I'll put that in between the carriage stop and the carriage. We'll crank this down. So this will be nice and repeatable. We'll be able to make 4 new pins with a shoulder on them, all at the same length. Well, I have version 2.0 of the 4-pin spanner wrench all welded up. I saved you the boredom of watching any of that again. So let me get this dividing head clamped back down to the welding table, and we'll try this new tool. Well, likelihood is that something moved a little bit during welding, so the fitment of this is not perfect, but a little persuasion, and that's a nice tight fit. I have some hope. I'll start just by using a ratchet here and see if I can't get it to budge. It's still a bit tight, so I think I need something a little bit longer. I've got a deep well 3/4 inch socket here with a 1/2 inch drive breaker bar. We'll see if that will give me enough torque to move this. Well, the breaker bar is certainly giving me the torque, and I can see it moving, but I don't see the spanner wrench moving. I think what's happening is that spigot, that press fit wasn't good enough, wasn't enough of a press fit. So I think what I need to do is put a little weld tack here between that hex and the tool and try again. Well, I welded that piece of hex to the back of the tool, and that's of course going to make it a little more solid. Let me put one of these pins into the welding table so that I can get some rotational torque on it here. I'm going to clamp down the front of it too, so it's held down in a couple of places as best as I can, so I should have the best possible chance of getting this thing off if the tool survives. It took a little bit. Didn't work on the first try or really even the second try or maybe not even the third or fourth, but I finally got that nut loose. So it is still really tight on the back of that spindle though, so I'll take my time, make sure I don't do any damage to this thing. And not having those clamps has proven to be a pain in the butt. I kind of wish I would have left them on. With that nut now off the back of the spindle, I'll disengage the worm here so the spindle is free to rotate, which means I should be able to drive it out from the rear. I'll start with this block of wood. I don't want to do any damage to the rear threads or to any part of the rear of the spindle. It is definitely moving, but I believe this flange here on the front is captive in the whole spindle, so it's going to prevent it from coming out all the way. It's just held in with a few screws. I can see that there's some kind of a keyed washer here on the back of the spindle. Imagine it's, again, something to do with the preload on this rear bearing, but it's so gunked up that it's taking a little bit of effort to get it off. I'm using one of the old table feed nuts off of the Bridgeport here to drive on the back of the spindle to try to not do any damage to the spindle, but I don't think it's going to quite work. So I think what I need to do is make a tool for this that will fit into the back of the spindle and help me drive this out. Well, need a tool, make a tool. Turn down this piece of scrap here to fit perfectly inside of the spindle, and this should make it much easier to drive the spindle out of the front. It's fairly tight in there. I'm a little worried about damaging it, but I don't know what else could possibly be holding it up. Okay, that was quite an ordeal to get this thing out, and it is fairly well caked full of grease. I can only imagine what the inside of this thing looks like. And my fears have come true here. The inside of this thing is absolutely caked full of old dried grease. You can't even tell that there's any kind of mechanism inside of this thing. It is completely full, and I mean full, of grease. I don't know why anybody would have done this to this tool. Just keep pumping grease into it. It would have never needed this much grease. But the thing is, the way this tool is made, I don't know how else you would have maintained this thing, right, to clear it of its old grease without doing a full disassembly like this. I don't know. Maybe that's what Brown and Sharpe recommended or is expecting someone to do. But this thing is bad. It is bad. I don't think I've ever seen even the Kearney and Trekker dividing or universal head that I took apart that was full of grease. I don't know that it was as bad as this. It was a lot more of it, but this is a lot of garbage in here, and there's just no excuse for this. I'd like to see if there's some way to remove this rear bearing just so I can clean it and check it out, make sure it doesn't need to be replaced. They're not super expensive. It's about $100 for this rear bearing. I don't know about the front one. Probably about the same from what I can tell. But it's not obvious how this comes out. Now, there's this ring around the back here that could be a retainer. Looks like it's held in with a screw. But I'm a little worried that if I do remove it, will I be able to get it lined back up? You know, if I don't have to take this thing out, I'm not going to. So I think for now, I'm going to leave the bearing where it's at. We'll try to clean it up once I get this thing fully disassembled, or at least more disassembled than it is. And, we'll go from there. If it feels good, then I'm probably just going to re-grease it and let it go. This thing doesn't spin at high rates. It's just there for accuracy, so it doesn't need to be removed and replaced with some special bearing if it doesn't need to be. In the meantime, we'll continue disassembling the dividing head by removing this nut that's on the end of this cam lock mechanism that's used to engage or disengage the worm drive for the dividing plates. Well, this other shaft that's in there, it comes out on this side of the machine. In order for it to come out, I need to remove this cover plate. But using a regular screwdriver is just not going to do it. I made this tool a long time ago for something else. I actually don't even remember what, but I think I can adapt it to be used to remove this cover plate. Well, future me here, this little removal process was way more difficult than it needed to be because I wasn't paying attention. I didn't do any damage, thankfully. However, I didn't recall from watching Keith Recker's video that there's a set screw on the front of the dividing head that's used to hold this piece in place because it does provide some kind of thrust, I guess, positionally for the worm drive. And because I didn't remove that screw, it provided all sorts of friction on the side of this cover. And it didn't do any damage, thank goodness, but had I paid attention and remembered what was in that video, I wouldn't have made this mistake. Thank goodness I didn't do any permanent damage to this part. With that cover off, now I can push out this worm from the other side. There is a thrust washer on the end of this that's just stuck on from all of the grease. Okay, what's next? Let's get rid of these handles off of the side here. This top one here is for the plunger that fits into that large plate that came off of the front of the spindle for direct 15-degree indexing. Underneath this second screw is a spring and a rounded over like plunger that sits in a detent, so this handle can be held in the other position. There's a very small slot head screw here that holds the handle onto this shaft. I really didn't need to remove this. I thought I did, so I did. But I could have left that together. Hopefully I don't lose that screw. Well, I think for the handle on the spindle lock, I'm just gonna keep it together, and we'll just unscrew it all the way. The shaft for the indexing plunger is a little bit sticky, so just needed to use a pair of pliers to pull that out. Had I left the handle on, it might have been a little bit easier. Same thing for the plunger itself. At least I'm calling it a plunger. Indexing plunger? I don't know what you'd call it. Anyway, just using a pair of vice grips and a shop rag here to make sure I don't mar the surface. Now I'm pretty certain there's either a ball bearing or something down inside this hole here that fits into the detent on that shaft for the handle, the pinion shaft. I can feel it. I just can't figure out, should it come out the top or can I get it to go all the way through? And it certainly feels like it's a plunger and not just a ball bearing. Just use a magnet here to remove that. Yeah, it's got a little bit of a rounded over bit on one end that fits in that detent in the shaft. Over here on the side of the machine here, there's a little retainer plate that holds this gear and shaft in and also limits its travel. This is the cam for engaging the worm. And when I tried to remove this screw, it split in half. So I'm hoping I can avoid needing to drill this out because that would be a pain. So I'm going to try using a punch and a hammer to see if I can't get this thing to rotate a bit. Well, it looks like I'm getting really lucky here with this one because it is turning. I will have to either acquire or make a new screw for this, but that's a heck of a lot better than having to set this thing up somehow and drill it out. Before I can pull that shaft out here, there's a nut on the inside of it. This nut is cut as a gear. It is when this nut is tightened, it prevents the worm from moving. Basically locks the indexing in position. But it's on here pretty tight, and I think that's mostly because of dried, caked up grease. So I need to spend at least a little bit of time trying to remove some of that harder grease to get this nut off. Well, I finally got that nut to come out, and with it came a thrust washer. This was actually pinned to the end of the shaft, and it just kind of came out with it. Likely because of all the grease that was in it, kind of forced it out to come with it. But I'm glad I have this stuff on video because it certainly does help me figure out how to put this thing back together. But before I can take that shaft and gear out, I need to get this shaft and gear off. And I don't know if this gear will come off the front or if I'm going to have to remove the nut off of the back first. So first things first, there's this collar that's on the end of the shaft that is used for the indexing plate. There's a screw here that holds it in position. We'll take it off and take this collar off and go from there. And it does not look like that gear is going to come off the front, so I am going to have to take the nut off of the back of it from the inside. Well, I needed to use a 1-inch, I think it's a 1-inch wrench to get this nut off of the back here, and this is a very awkward position to be in. There is not enough room for me to put a socket around it because that nut is right up against the inside of that casting, so there's just not enough room. So I've got to use this wrench and do what 1/8 or 1/8 rotations each time. So this will hopefully I don't know how I'm going to get it back in there and get it tight, but for now we'll do what we have to do to get this nut off. Well, the shaft is kind of stuck in there. I don't know if this is a press fit or if it's just tight from age, but I'll use a brass drift here on the end of it and drive it out. Well, I should be able to go ahead and drive this shaft out from the other side since there's nothing else holding it in. And, future me here, there's also another thrust washer on the inside of the casting that was stuck there because of all the grease. And it didn't come free until I got this thing in the parts washer. And after, 20 minutes of washing it, and trying to dissolve some of this grease, did that thrust washer make itself known. Well, a little jump in time here. While I was washing this thing in the parts washer, I found the brass end of the spindle lock. And while I was doing that, I realized there was this other pin that was in the opposite side of the dividing head. And I realized that was capturing in this other piece. I don't know what this is, but I think it's something to do with the rear bearing. But this pin on the side is actually threaded, and I think it's threaded so that you can pull it out. I didn't think to do that, so I ended up driving it into the center. I just need to drive it a little bit further because it is a perfect fit, really, for the inside of this machine surface on the dividing head. But I'm glad I was able to get that out because now I have more access to that rear bearing, and so I can properly clean it. Well, now comes the real time consuming part, and that's getting this stuff cleaned up. There is so much dried grease inside and outside of this. I'm not exactly sure how I'm going to clean some of it. The small parts will go into the ultrasonic, but these larger pieces, there's some galling here on the back that made it a challenge to get this thing out of the base. And I'm going to need to stone that, take some Scotch-Brite to it. I don't want to put this thing in the ultrasonic because of the bearings, because that's supposedly bad. Even though I've done it before, I'd rather avoid doing any damage. I still can't figure out how to get this rear bearing out. I'm almost certain it's because of that ring, but I don't want to take it out. The spindle itself, again, is caked in grease, and I think this one is just going to get soaked in degreaser. I think it will get most of it off. Again, I don't want to put this in the ultrasonic because of those bearings. There is another spanner nut on the back of this, but I'm going to leave it together. If I don't need to take it apart, I'm not going to take it apart. And I don't think I really need to, but we'll find out once I start getting this thing clean. If I can't get the bearings clean enough with, degreaser, acetone, brake clean, and whatnot, then I'll consider taking the spindle apart. I just don't want to damage the bearings if I don't have to, trying to get them off. Well, that's about all the time I'm going to have for this video. I think I'm going to have to call it quits here. I'm sure this video is going to be pretty long. I'm going to try to edit out as much as I can, but I've got over 3 hours already recorded, so we'll see how much I can get rid of and make it reasonably length. But I'm going to have to spend a whole bunch of time cleaning this stuff up. I don't know how long that's going to take. Hopefully I'll get it cleaned up enough where we can start reassembling it next week and start showing that in next Sunday's video. I don't think I'm going to be able to get this video released by my normal Sunday at noon video time, but hopefully shortly thereafter. Anyway, I appreciate all you that have subscribed to the channel. If you're not a subscriber, please consider hitting that subscribe button. Hit that like button if you enjoyed this. Drop me a comment. Let me know what I did right, what I did wrong, or what you would do differently. And a special thank you to all those that are supporting the channel either through channel membership or through Patreon or through PayPal. It really does mean a lot, and it helps take care of some of the smaller incidentals that go on inside the shop. Anyway, thanks for watching, and we'll see you on the next one.